So the class is Digital Communications, and I am Leslie Rusch. This is the way that you can reach me. Of course, in person is very difficult now. Telephone, probably not so great. You can certainly reach me by email, and you can also reach me on Microsoft Teams. And that is a good way to reach me because it creates a chat that actually goes to my cell phone, and so it's something that is the most likely that I'll see. I mean, email works fine, but I get a lot of emails. Teams, I'm gonna talk about it a little later, and it's another way that you can reach me. And a reminder, class is online Tuesdays. Now I think everyone's probably figured out which time zone adjustment you need to make. I know that we have people phoning in from different parts of the world, or zooming in from different parts of the world. And I chose this time slot because I thought it was the one that perturbed everyone's schedule the least. So I'm a professor at Laval University. I'm actually from the US originally. I was born in Chicago. And I did my undergraduate work at Caltech and my graduate work at Princeton. And then I joined Laval University as a professor right after that. I've worked at Intel for a couple of years. My specialty is in communications, mostly in optical communications, although I've done quite a bit of work also in wireless. So I have interests in both, a little bit in networking. So this class that I give is really a class that I like very much. I'm very passionate about it, and I hope that I can transfer to you some of that passion I have for the class. There is a teaching assistant for the class. It's Rizan. Rizan, I have her email address here. And again, the slides that I'm presenting now are also on the website, which I'll be showing you later how to reach it. So you don't have to write down this address, but she's available. Mostly she'll be working with you on a project for a virtual lab for the class, but she's also generally available if you want to discuss some aspect of the class. Talk to you about how the class is going to be evaluated. There's going to be two series of homeworks. One I call sort of like a general assignment. It covers a couple of the basic concepts for the class, and especially the general assignments are trying to get you the background needed in order to do the project, which is the virtual lab. There'll also be another series of homeworks which is dedicated to simulation. So this will be simulating actually an optical communication system and give you an idea for what are the issues, what are the techniques we use in simulation of optical communication signal systems in general. I think that I try to make this class sort of a strange mix of practical and theoretical. So I don't just give you, this is like all of the kinds of communications modulations there are, and here are all the equations, and that's it. I try to give you enough background to understand why we end up with these modulation formats. Where did they come from? Why are they taking the form they are? Because I think that will help you understand under which circumstances you might want to make each one. So that, I think, is somewhat the theoretical part. I don't just come up with equations. I try to develop them and show you where they come from. It's not that I want you to be able to develop the equations. It's not the objective. The objective is to have you understand and appreciate where they come from, and to try and give a more, I like to think of it as a more in-depth understanding of communications and why we do the things we do, the way we do. But there's also a very practical part, which is these simulation assignments and the virtual lab. Some of you are going to be working in the laboratory for communications eventually in your research, and I try to give you some of the skills that take this background theoretical approach to communications and how you would actually apply them. Like I said, I think you'll see a mix in the class. There is 15% of the grade which is going to be based on in-class participation. So you'll see that the way I've organized the class is to have many hours of lecture which are recorded, posted on YouTube that you listen to ahead of time. And then after you've listened to the week's worth of lectures, we'll meet on Tuesdays. And on Tuesdays, I'll try and really get a discussion going. My hope is that we are not me talking or you being shy about asking a question. So certainly it's a time for you to come and ask me questions. That's for sure. But I'll also be asking you questions, and that's because I've been in this situation before where people don't really ask questions, or they ask questions and it becomes very one way. I would like to have a two-way conversation. Of course, it's not two-way because there's 10 of you and one of me, but I'd like to really try to help you understand some of these concepts, and maybe they'll be clear to you, and maybe when I ask some questions you'll be able to demonstrate to me that sure you've done the preparation and you actually have no problem with material, or maybe we'll discover there's something that wasn't as clear and could take some more time, and we'll do it together. So I hope that we will be able to have this as interactive as possible. So that is why I've asked everyone to show up in class, because I will have to evaluate you on this preparation and discussion. I understand that sometimes schedule doesn't permit, there's some conflict, and it's not that I'm going to be taking attendance, but you have to be present enough for me to evaluate this. And at 10, I don't know if we'll have a chance for everyone to speak in every meeting. That's not what I'm trying to accomplish either, but I will definitely try to make sure that everyone has got a chance to speak at several of our meetings. So that's the in-class participation. Oh, I forgot to say, I think it's 15% of the virtual lab. The project will be a virtual lab. I think it's also 15% of the note of the final grade. And the project is going to be one where you create in MATLAB a file that represents a signal that you want to transmit. We'll have the teaching assistant actually go down to the lab, generate the signal that you have provided her. Then she'll send it through the channel, which will have been explained to you, and she'll capture the result of that transmission and send it to you, and then you will do some post-processing on the signal. So, in an ideal world, you would each go to the lab and do this yourself, but since we're working from a distance, we'll be doing it this other way. But it will still give you what I mentioned before, which is this sort of practical aspect about what you would do in order to apply some of the concepts that you learn in the class. So the virtual lab, you have to gather the skills to be able to do it. So probably around midway, about the halfway mark, you'll start having enough preparation to start doing many of these things. So the general homework assignments, for instance, will come earlier in the semester. The simulation assignments will start right after the break. And the virtual lab, you'll start working on it after the break, and it will take some time, and then it's actually due at the very end of the class. There will be 2 exams. There'll be a midterm exam and a final exam. And these exams will be open book, but they will be timed. So you will take the class time to run these exams. And of course, they're for individual work only. And you will have a limited amount of time to respond to the questions and submit them online. And I'll be telling you more about that as the exams approach, but you will be sure and reserve your time for those exams. So there are some important dates because of that. The homework, there are some approximate dates on the web page, but the exact dates will be updated throughout the semester. I'll try to balance the workload. So I have to try and balance when you have enough understanding to do the homework. So it sort of makes the second half of the class much more loaded than the first half, because it's hard to test you on things because you haven't seen everything yet, especially for a simulation where you want to understand the concepts that are being simulated. So just warning you about that. Exams, like I said, they're going to be in class. What I mean, they're going to be synchronous time exams. They'll be on the 20th of October, again, in the slot. I think I have an hour and a half reserved now. It might go to 2 hours. I might want to give you a little bit more time on the homework, on the exams. So it might be a little longer, but it'll definitely start at 10 and go on maybe a little bit longer. And those will be on 20 October and 15 December. And the project, as I mentioned, will be due at the end of term. Any questions so far? Feel free to interrupt me at any time. If I'm going too fast, let me know. Like I said, I can't see the chat. I'll see if I can do that in the future, but for now I can't. So just interrupt me. Okay, so we'll see that there are many sources of information available for you for the class. There is a textbook that I use for the class. Let's see if I have it here. This is, oh, maybe you can't see it. Maybe you can't see it on your screen, but it's Digital Communications by Sklar. I did not order it through the bookstore on campus because I'm not sure how many people are on campus, but it's available from many sources. I use it pretty much. I try and follow it, but I do a lot of supplements to it. There's some things that he covers in great depth, more depth than I want to, and some that he glosses over. That's true with every book. I do think that it's an approachable book. I think it's readable, and that therefore maybe you can get a little bit more out of it. Now there are some other textbooks which are more exhaustive, I would say, like ProACUS, Digital Communications. I really like it. It's an excellent reference book, but for a student, I think it's a little hard to read it. It gets, follow the flow of ideas coming through. It's a little dense, but it's great for reference when maybe I'll go through a first layer of equations, but if you really want to get down deep into different aspects, different approaches, it's a very good book. Ziemer and Tranter, Principles of Communications. That's one. It's a little more approachable, so it's a little easier book to read. So these are some alternatives, and they're all classic, popular communications books. Any of them would be able to help you follow the class and understand some concepts if you want to read a little bit more. Of course, there's going to be a lot of information available via the webpage for the class. There will be YouTube videos, which are the lectures that I present on all the material that's being covered. I try to point out which sections of the Sklar book back up what I'm presenting. Sometimes there are websites that I can give you a link to that might talk about it more if Sklar is not very in-depth on it. Some excerpts from books I'll be adding when Sklar is particularly not very, expansive on it. All the PowerPoint that you see that I present will be available as PDF online, and all of my previous exams that I've given in this class are also available online. Most of them are available in English. The solutions are almost always in French, but there's a whole lot of equations. But let me say that if you ever come across a previous exam, it's in French and you don't get it, just send me an email and I'll be happy to send you an English version, and that's good for me because I want to build up the website in English. So I'm going to be doing this anyway, and if I don't get to the one that I should and you're interested, please let me know and I'll be happy to provide you with that. So now I'm going to take you through the web pages for the class and what kind of information you can find and where to find it. And there's two web pages that I use. The university has a private web page provided for all courses. I kind of prefer to have a public web page because I think that could be useful for students who are not, perhaps not officially taking the course, but could benefit from having access to the material. Also, people who maybe are having problems accessing the VPN or other necessary prerequisites for getting to the private website. So most of the course materials, practically all of the course materials, will be available on the public website. And the private website for the university I reserve it for the information that is private. So for instance, when I report your grades individually to each of you, that will be going out through the university private website. And that one will also be where I post, for instance, the Zoom link, because there's a lot of Zoom bombing and I don't want to make that public. So it's important for you to be able to access both websites. And I'll start with the private one. So for those of you who've been at the university before, you're very familiar with it. It's called Mon Portail, Monportail. And again, maybe you could take a screenshot of this if you are worried about not getting the links. Once you get these links, you'll be able to find all the information. So this, for those of you who have not, this is your first semester and perhaps you're less familiar with this website, if you want to talk about it more, stay on the line after we've finished with the class, and I'll be happy to talk you through it or explain anything that you're not sure about, or discuss issues with you about that. For the public, I mean, it's public, but it's housed on the university website, but for the department rather than for the university level. And so I will go ahead and start to share the other site. Let me see. Seems to be that one. Okay. So now you should be looking at the Mon Portail website. So Mon Portail, when you go to that, you will log in with your university ID, your university password, and it will give you a list of all your courses, and then you will select the Communication numérique, Digital Communications class, GEL7014, and you'll come to this web page. Maybe you'll come to the introduction, and I think on the introduction I haven't written anything. So we'll go to Information Générale, General Information, and there you'll see most of the information. There's a section in French at the top, and then the English version at the bottom. So it's the name of the class. Teaching method, we call this a virtual hybrid because we will have sessions at a specific time online, and that's the hybrid, but there also will be, most of the material will be asynchronous, that you'll be doing the lectures on your own. Here I have the link to the public website so that you'll be able to find it. Let me see if I can make this bigger because I suspect it might be a little small on your screens. Okay, good. A little bit wider maybe. So we have, as I said, a link to the public website, schedule, sessions may be recorded. Here's the link to Zoom with the password embedded in it. And then I have something like a link to the chat, and there's an address there, and I'll be talking to you about how we can exchange information at that chat. So all of these links are available, as I said, in the section General Information for the class. This is my web page, and I guess that's it for this section. Course description, this is what the objectives are in general for the class, an idea of what we're going to cover and when, although I think the order is not, I think I've changed the order to try and make it line up with the homework a little better. I think that this is empty when I say activities and content. I remind you to go that all of the content is actually going to be on the public web page. This is where it says evaluations and results, and this is where you'll be able to see your grades reported to you. There's a lot in French about the rules and regulations, so I suggest that you use some Google Translate if you need to understand what's required. There's going to be no big surprises here. Because of COVID, we require that everybody be very flexible. I've put in the dates. The dates, I'm going to do my best to respect them, but things could change due to the situation, and modalities of how we give the course could change because of this. And of course, you'll be informed. Even though we're going to do evaluations that are not being proctored, you're not going to have somebody looking over your shoulders. That doesn't mean that the rules on plagiarism or cheating have changed. They're all the same rules. When you do a homework assignment, it's to be individual work that you turn in. I don't mind you working together on homework assignments. In fact, I encourage it. The more you exchange ideas, the more you talk about what you've learned, the deeper the learning is going to be. So by all means, set up chats, work together on your homework. But at some point, it's time to put your ideas down on paper. And I try and put in the homework quite a bit of discussion, and all that discussion should be your own. So it should be the fruit of that working together with others, is that you come to your own understanding of what's going on and you write it in your own words. And that's what I expect to see on the homework that you turn in. What else can I say? The exams particularly are going to be open book. You know, I understand that, of course, you can access any material during the exam period. But that doesn't mean that you can talk to somebody or have somebody help you with the questions. So that would be definitely not allowed. So please don't misunderstand what is happening here. And if you have any questions about this, please feel free to talk to me. Okay, so that's my take on what's going on in French here, but I suggest that you make an effort to understand yourself. Here is the scale for the grades as it come out. So you'll be given numerical grades on your homework and your exams, and this is how they translate from a numerical grade into the letter grade, which is assigned. So here is a reminder about the evaluation. And you can see there's a midterm exam, final exam, the dates are given here. Participation online Zoom. Now here the dates are, you know, not really relevant. For the exam, the date is very relevant. Of course, the grade on participation is going to be coming out at the end of the year. I will try to give you a midterm evaluation of how you're doing on participation in case, you know, you may need to make an adjustment in the second half. So I'll give you feedback right about the time of the midterm on your participation, but the final grade is going to be entered one time at the end of the year. So at the end of the year, I will officially report your grades for the homework and the participation. However, probably by email, I will be giving you feedback along the semester, even though the final grade won't be entered into here. Okay, I think that's covered what I wanted to cover here. I think I have material didactic. It's not linking to it, but that's where the textbooks are listed. Yes. So it's textbooks here. And then there is something called the plan de cours, and this is the sort of summary of everything on the web page that gives you the information that we've been discussing. So it's another form that you can look at it. It's an interesting mix of English and French. Okay, so this is the private web page. And now I'd like to go to the public web page. And as I mentioned here, there is a link to the public web page. And this repeats some of the previous information, but here are the sections that we're going to focus on. And I'll start with logistics, then we'll go on to course notes, where the homework will be reported. These exams are previous exams, and then maybe some other place for other information. So I'll start with logistics. And again, there's course online meetings, Tuesdays at 10 a.m. Meetings may be recorded, and the Zoom link, if you have to go to the private web page to get the Zoom link. I sent it to you by email to make sure those of you who didn't know how to log on maybe would have a copy of it. It's the same link every week, so if you have it, you're good. Course materials, and this is a link to this website. Course grades are found on the private University one, textbooks, and then the chat forum. Again, here's a link to the Microsoft Teams channel, and I'll be showing you that after I go through the rest of the webpage here. So course notes, this is where you'll be finding all the information relative to the class. So first, at the top, I tried to get a YouTube playlist of the course videos, so they'll be lined up one after another so that you can see the progression or have one link to go to all of them. For instance, like now if I click on Introduction to Class, you'll see the PDF that I'm presenting to you today. So you can always get a PDF document of the PowerPoint I present. And I'll be adding a video also to give you, like I said, if you want to go back over it, listen to it, focus in on some sections that were hard to understand when I was going in. Now, week one, you'll see that next I give a section from the textbook to tell you where to do the reading. And I try to give you some objectives. You know, what are we trying to accomplish during this section? What are you trying to, you know, what is the key ideas that you want to get through? Then I'm trying to break down the presentations into some smaller sizes and try to make them some sort of logical ideas. So for instance, there would be a section on filtering and one on bandwidth quantization. How do we define bandwidth in different ways? Then I'll go to another section, and again, objectives, what your skills you're trying to acquire, knowledge you're trying to acquire when you're doing this. And again, there's always the link to the PowerPoint and a link to the video on YouTube. And they're all going to be different lengths depending on the logical unit that I used. This week one is going to be really a lot of lecture, more than other weeks, because it's mostly, everyone comes with a different background, and I want to try and sort of set the baseline of notation and previous concepts that will be used during the class. So you probably have at least 1 extra hour of lecture this week compared to the norm going on here. So don't be discouraged because like it seems really long, but try, and I also think that you have a little more time at the beginning of the semester, so it's not unreasonable to give you a little extra work this first week to try and get us, you know, firmly established. And then starting in week 2, we'll start to get more of the normal pace. I've posted the reading for the next week, but the videos I'll be preparing in the next week. So, for instance, when we come back next Tuesday, this is the material that we will be discussing. So we'll be discussing everything here that's listed under week 1. Then on Tuesday, we'll discuss this. So you should have gotten through all of this material in time for the class on Tuesday. Homework will be posted here. There's going to be like a set of basic concepts, and again, these are in many ways trying. Oh, I think I'm probably going to change that. Well, we'll see. We'll see. I'm thinking now when I'm looking at this, maybe I'll want to make some adjustments. The total percentage will not change, but if I might do it over 3 or 4 assignments, because I can see now it's week 3, 5, and then not till 12, and it's a little unbalanced. So I'm going to do my best to balance this, and that's why I say these dates are just approximate. But the idea is that this homework A is a set of ideas that are going to really be important for you to be able to do the virtual lab. And these are skills that you'll need in order to perform on the lab. System simulation, that's like a separate effort. And, you know, as graduate students, often part of your research is going to be to simulate some sort of behavior. And so I'd like to give you an example for a communication system. What are the best known practices for good simulation? And we take as an example. So in this simulation, I'm going to give you 90% of the code. You know, it's not that I want you to write a lot of MATLAB code, but I want you to be able to exploit the MATLAB code. So this is where I will be posting the homework. I think for the first homework it's available, so there will be an assignment, describes what you need to do, and then there would be a zip file with all the files you need, and then you would have to run certain software enabled to, like MATLAB, and some other software, and that will be there. And eventually I'll probably have a video also that would give you some tips on how to do the homework. Exams, these are previous exams. So for instance, their midterm exam and final exam, and there are, here I'll be telling you which sections are covered. Then objectives, this is in French, I'll be translating it. It's basically what I'm presenting on the page, on the course note page where I said these are the objectives, these are the sections. I just bring it back together in one document, everything that's covered on the midterm exam. And then I'll also, there's always some essay questions on the exam. I think this is still in French, I'm sorry. I'll be moving it to English. But I take, from previous exams some essay questions, and I think it's important. These are the kinds of things that I want to discuss when we meet together. So I want to ask you something that would be similar to a question I would ask in an exam. Give the definition of binary orthogonal modulation. What is that? And I think it'll be great preparation for you for the exam, because if we do it together, you'll have an idea of what I'm looking for, what's a solid response, and give a chance for us to find any things that are unclear and to clarify them. So in the previous years, I would provide certain notes, course notes that was allowed during the exam. So these would be the information that was provided to the student as notes, because it would be a closed book exam. So I'm giving you this just so you understand. Down here, when you look at past exams were in class, closed book, 3 hours, and the notes were provided to the students. So of course we're not going to have that environment this year. So because of that, these past exams, I'll give you some idea of what I'm trying to test, what I think an exam is able to test. But you have to understand that it's not going to be, it's certainly not going to be one-to-one, because now it's open book. I know that you have access to all the solutions of previous exams, so I'm going to have to change it to make it reasonable. So the exams are available in French and then in English, but the solutions are in French only. It goes over many years, and you'll see that they're not the same every year. Some things are covered differently because, of course, there's an evolution of what material was covered during the exam. But it does give you an idea of the type of exams that I give. And they're also just a good way to test yourself and see if you really understand what we went over in class. Additional information, that's just sort of a catch-all. If I see something interesting, find a website that seems to expand or clarify, I might put it down here. Although when I went to update this page, a lot of the links I've used in previous years were broken, so I have to sort of reevaluate that. Here are notes from practitioners. So when you go to the part where you have to do the virtual lab, these are notes from equipment suppliers. So if you want to know about practical aspects of using the equipment, which will be used in the lab by Rizan to generate results, I think these could be very useful for the project part. So that is content so far. Any questions? Okay, let me move on then back to the PowerPoint very briefly. Okay, so we've gone over the two web pages, the private one and the public one. And now I'd like to show you Microsoft Teams. And you saw that there were links on the web page. I guess I'm going to go right back to that. Let's see what I can do. let me start from the web page. I said logistics and then chat, and I said there's this link to a Microsoft Teams channel. So those on campus already perhaps have already been introduced to the use of Microsoft Teams, but maybe not, because this is still something fairly new that has been adopted very rapidly on campus. And certainly for the new students, maybe this is entirely new. So this software is available free to all students. You have to go through a website to download it, but it's a means of, for this course, we're using it for a chat. So it's like a forum, a place that we can exchange ideas easily, and is well integrated into the university system. So without further ado, I think I'll go over there. So you can click on that, and then it says you can open Microsoft Teams. So you could use the web interface, but it's much easier to have it downloaded permanently on your desktop app. I think I'm going to have to switch now to the other share. So this is the Teams environment. Whoops. Teams environment, and you'll see that there is a section of posts and a section of files. And there are no files yet, but if I did want to share a file with you, if I had a correction and maybe you didn't notice that, maybe you downloaded the old version off the web page and I had updated it and I want to make sure you got a copy, maybe I would put it here. This is visible to everyone, so it will not be where you're turning in your homework. I'll try and do something else for that, or your exams. I'll get myself organized. But for now, this is really just for chat and for broadcasting, if you will, what's going on. So what I suggest you do is, if you want to send a general chat, let me see, I don't think I can make this any larger. Maybe if I make it smaller, it'll be bigger on your screen. I'm not sure. So this is a test, and now everyone should have, if you had Teams open, you would get a copy of it, but you wouldn't necessarily have been, you won't be pinged about it. So if I wanted to send, like I wanted Ariane to get a copy of this, Ariane, don't forget, come to class. I don't know. Then she would get a little ping that said, oh, Ariane, you were specifically mentioned in a post. So if you have a chat going and you're having a chat with somebody in particular and you want to make sure that they notice it, because it will always be delivered to the person, but they won't necessarily have noticed it. So now you'll see that I got a little thumbs up because Ariane, gave me a thumbs up to let me know that she had seen the message. So it's very useful. And if I want to make a post to everybody, and I want to make sure you get pinged on it, that you really notice it because it's an important notice, then I'm going to put @GEL, and the whole name of the, I guess I have to put it in caps, the channel. And now that will ping everybody. And so you will get something. And so, this is just a first example of how we can use Teams as a way to exchange information. So all the people, all the students registered for the class are on here. Rizan is also on here. So when you post something on this, everybody gets to see it. So this is really a chance to exchange information. Because we have many members of the class who are calling in from another continent, it's like I said, I encourage you to discuss things together. I encourage you to discuss the homework. This is what I got when I did it. Did you get this? This doesn't make sense to me. What am I doing wrong? This is an excellent place to do that. And I'll be monitoring it, and when I can, I'll answer it, but I get busy, and so maybe I won't answer it as fast, and maybe some of your co-workers here in the group will be able to help you quickly and understand where you're coming at, because they were just doing it and I hadn't looked at it for a month or so. So please feel free to use this, and we'll try and make a good tool out of it. Don't be shy. I know that some of you, you don't know anybody at the university, but this is, unfortunately how we're going to have to live for the semester, and let's try and make the most of it and get these tools to help us. Any questions? Okay, let me see if I can get back. Okay, so we're back here. I'm going to mention the software that you'll be needing during the class. We're going to use MATLAB software a lot. There is a university license for MATLAB. There are also student versions of MATLAB available, but you will need to use it. Agilent VSA software, vector signal analysis software, is something we'll be using for at least 2 homework assignments. And that, unfortunately, we have limited number of licenses. So in order to access that, you're going to have to use VPN and a Microsoft Remote Desktop. And I'll be giving you more information about that when the time comes, but it wouldn't hurt for you to make sure that you can get the software available and test that you can access it. So virtual private network, a VPN, this is software that even though you're working from some remote site, it connects you into the university environment. And of course, there's a lot of security protocols that limit access to only those who are on campus. I don't think that that's mon portail, I think you can get from anywhere. But there are some resources, and one of the resources is this Agilent VSA software. MATLAB could be installed locally on your computer, but you would need VPN in order to get a license from the university to use it. So there's 2 ways of working with VPN. One is with a web interface, and that is at this web page. And the other one is an app that you download and that you run on your computer locally. And this is a place where they describe how it is you can download this software. That's what I use here. This would be when you run this software, this is what the interface would be. And you would connect and log on using your university logon and password. So I encourage you to get used to using VPN if you haven't already, because it will be an important tool in order to access this software. Certainly for MATLAB, I'd like everybody to try and connect with MATLAB and let me know if that doesn't work, then we'll have to get somebody to help you. And the sooner we discover this, the better. We don't have to have the homework assignment, due in a week and you still haven't figured out how to use MATLAB. So if you take some time to make sure you can do that. The VSA software will deal with that when the time approaches. So Microsoft Remote Desktop is a way of logging into a computer which is physically located on campus. Well, it could be used more generally, but the application I'm thinking of now. So we have a set of like 100 computers on which this Agilent VSA software is installed. I think we only have 15 licenses, but that's enough for this class. Everybody can have access to a license. But you have to log on to one of those computers remotely, and then from that computer you run the software, and the software gets a license from the university server. So in order to use Remote Desktop, you need the IP address of the computer, and that I can provide you when it comes time to use Agilent VSA. But if you could just make sure that you have this software and have installed this software, and then when we need it, you'll be ready to go when the homework assignment is on. Okay, so now that's pretty much it for logistics, and now I'm going to dig a little bit more into course content. Just give you now an introduction about what it is we're actually going to cover, not just the mechanics of the class. So let's start by talking about prerequisites. What do you need in order to follow what we're going to look at in the class? And there's 2 prerequisites for the class. One is signal analysis, which is the GEL 2001, And, you know, if you're coming from outside of the UL, Universite Laval system, you might have had this class called Fourier analysis or signals and systems. Basically, it's the idea where you learn about time domain and frequency domain. Very important concepts for communications. And so we're going to rely on this a great deal. So this is a very important prerequisite for this class. One of the most important concepts to come out of signals and systems is the idea of filtering. And because of that, I take a few minutes, half an hour of lecture to just go over the key concepts from signal analysis that I want to remind you of. So it may have been several years since you studied this class, and maybe you've used it since then, maybe you haven't. So it's a good time to refresh on the concepts, and I bring out the ones that are the most important for you to remember. The other prerequisite is probability for engineers, and this is first year probability class, first year undergraduate probability class. So the most important thing we get from this is, you know, how do we calculate an expectation? What is a mean? What is the variance? Very important to use the Gaussian distribution to understand how to calculate CDFs, how to calculate a probability that a Gaussian random variable falls in a certain region. You know, we use that excessively in this class. And I don't think I go over it specifically as a separate lecture. I think for the filtering, I go over it as a separate lecture, but the probability, I go over a little bit, yeah, the random processes the first week. So there's the undergraduate probability class, and then there's a graduate level probability class, which we would call random processes. And some of you have taken this already, some of you have not, some of you will. So we come as a class, as a group, to this class with different kind of preparation. And so I try in this first week, one of the lectures that's recorded is to give you the basic ideas that you need. Okay, so I don't know which course you've taken, but I sort of say this is the concept that you need to know. And especially for the graduate level probability, which talks about random processes, I give you all of the descriptive that you need, but I don't expect any manipulation of random processes in this class. So I give you some examples. I'm trying to give you a little bit of sophistication, if you will, so that if you come across in your reading something that says random processes, you'll have some idea of what it means, but you don't have to know everything about it. That's another class. That's a separate class. So what's required as a prerequisite is the basic manipulations that you had in undergraduate, and maybe a little bit of familiarity with the vocabulary of an advanced one, and I provide you with that. Now I put in gray here something that's not an official prerequisite, but it's sort of like it's complementary to this class because it does things that I don't do in digital communications, and that's GEL 3006 here at Laval, but it's what we call a basic communication systems course, and it will cover analog communications, it will cover line codes, power budget, propagation, you know, all kinds of basic concepts of communications. And in digital communications, we don't do that. We put that aside. It's not like I assume you've done it, but I just don't feel any responsibility to cover it. You know, to know all about communications, you would also need to know about this. And I'm not teaching that in this class, but I, you know, assume that you will get that understanding from some other class so that I don't have to cover it. Okay, so that is the view of what you need to come into the class. And now I'd like to talk about, you know, what is special about digital communications. Why are we interested? Why is this course important? Why is it great that you're sitting in this class and following it? And you know that digital is everywhere and analog is much less common for communications these days. But you know, have you thought about why? Why did we end up here? And these are, I'll give you some basic ideas, and that's what we're going to cover the course is. I don't want to just say the how and the what, but a little bit of the why we're going that direction, and then how we ended up getting there, and then the what, you know, like what are all the modulation formats, etc. So first of all, when we talk about digital, what is digital? How does digital distinguish from analog communications? Digital is basically a finite number of states that I have to communicate. So communications is point A, point B. Something here has got to be known at this other point. So that could be my voice. I would like this lecture, the video, or the slides. These are information that has to be transmitted. And if it's my voice, my voice is analog. It's not digital. My voice is analog, and radio broadcasts existed hundreds of years ago, well, at least 100 years ago, and this was the way I have an analog voice. I would transmit it analog. What's different with digital is it's not like any possibility of the certain range. It's not a real variable. It's a discrete variable. Okay, it's a finite number of states. And the most common one is binary, 2 states, logical 0, logical 1. But we'll also be talking about M-ary, so not binary, not tri-ary, M-ary. And that has M states. And it has an alphabet of M symbols. So binary, we talk about bits. And so we're going to be talking about an expansion of those ideas to talk about an alphabet. There could be more. But that's clearly what's digital. There might be 2 or there might be more than 2, but there's always a countable finite number of states. And of course, analog, infinite number of states. My voice, there's any voltage range possible created by a microphone that records my voice. So it could be digital, could be analog. Why do we go with digital? And you might say, well, because we have computers and we know how to flip bits back and forth. And yeah, sure, that's part of it. But there's really one reason that is the basis for digital communications. And it's regeneration of the signal. Now, one thing that's hard to do online is switching back and forth between PowerPoint and writing on the board. I have a board behind me, but it's too small for you to see. I have a couple whiteboards, but I'm going to try and use it now. I promise that for the next time, I'll make sure I know how to use it. But let's see if we can make this one work. Oh, already it's not working. Okay, next time. It works at home because I have no security on my link, but this one does. So I'll try and talk it through you. Analog. I want to go from point A to point B. Point A and point B are very close to each other. They're so close to each other that the signal is really strong. Signal is so strong, I have no problem. I can just shout. And people are so close they can hear it. Now, they're far enough away that I have to use a microphone, I have to use a wire, and then there's a speaker, and then, you can hear. It's kind of a communication system. It's analog. But the farther away I get, the more attenuation there is to the signal. That's just physics. The signal gets attenuated. And as it attenuates, it gets to a point where I can't understand what's being communicated anymore. It's no good. So what do? I say, well, okay, I'm going to amplify. So I have attenuation, I'll put an amplifier in. And that works great. It's just that by the time I've gotten kind of far away, there's noise that has been added to my signal. And that's what communication is about, signal and noise. So there's noise, and when I amplify not just the signal, but I also amplify the noise. And so I often say it's kind of like making a photocopy of a photocopy of a photocopy. Each time you make a photocopy, it's a pretty good copy, but it's not perfect. And if I keep making copies, that means that eventually it gets more and more noise accumulates. And eventually, even though I'm making an amplification, it doesn't work anymore. So I can't get all the way to the moon or, as far as I'd like to go because it's not a strong enough signal. So how is digital different than that? How is digital inherently more able to go? I can amplify a digital signal just like I can amplify an analog signal, but I'm also amplifying the noise. The difference is that because of digital, I have only a finite number of states. That means, let's take it. It's either a 0 or a 1. And so instead of taking my analog signal that falls, let's say, between voltage 0 and voltage 1 volt, where some noise accumulates, and I amplify the noise as well as the signal. And regeneration, I actually make a decision. Was it a 0 or was it a 1? And so when I make a decision, was it a 0 or was it a 1, and I retransmit, that means that I've eliminated the noise. Because when I retransmit, it's not the 0 plus the noise that accumulated, or the logical 1 plus the noise that accumulated. It's a new, pristine, regenerated 0, 1, absolutely no noise. So now it seems like I can go an infinite distance. I just need enough repeaters. I just need enough regenerators. Of course, you could make a mistake. You could say, I'm going to make a decision on whether it was a 0 or 1, get rid of the noise, and then if I make a mistake, then that mistake gets propagated. Well, that's bad. And what we can do is, well, we just make the distance between regenerations small enough, and certainly there'll be some point where I just don't make errors anymore. So digital allows me, I'm not saying it's cost effective, but I'm saying with digital, I can go as far as I want, because all I have to do is have enough repeaters. Keep the points close enough so that there's almost no errors, and then I regenerate without noise, and so I can go as far as I want. And that's the real reason that digital killed analog, because we could do so much more. Now, of course, I said no matter the cost, but it ends up that the cost came way down too. So not only does it offer us the possibility of a solution that analog does not offer, but it ends up being a very cost-effective solution. So what are the benefits? It's more reliable. Okay, so I already said you could go as far as you want, but now I'm going to say about, like, what are the practical reasons that it was adopted on top of this, theoretical reason why it would be better. And one of them is just simply more reliable. I mean, we can just do more to make it less likely to go wrong. And there are many reasons for the reliability, but a big one is that we can use something called error correcting codes, in order to make sure that we're not making many errors. I said we could always move them close enough, but we don't actually have to move them that close. We can keep them pretty far apart so that we keep our costs down, so we're not having multiple repetitions, because we have this special mathematical technique that when it encounters an error, recognizes it was an error and corrects it. And I think it's like magic. I just love error correcting codes. We'll look at them at the very end of the class. There's a whole course in error correcting codes which is offered at the university, and so we're not going to cover it in that depth, but it's still so important in communications that I'd like to give some understanding of the concepts about why it works, what it can do, what the limitations are. So we'll spend a few weeks on error correcting codes. Digital is cheaper and smaller. VLSI integration has led to digital electronics, the cost just going way down. We've been shrinking the size of them. So all of these things have tended to make them very, very, very competitive. So all of the extra like error correcting codes can be done in digital electronics. Last part is it's just incredibly flexible to use digital. There's just so many ways we can attack the problem of getting from A to B. A and B could be ship to shore. It could be cell phone. It could be from here to the moon. It could be from here to the ends of the solar system. There are just so many diverse requirements for communications. Just each one of those links I've described has completely different operating points about what kind of bit rate we want to use, what kind of cost we're willing to put up with, what kind of reliability we need. So every one of them, in what's great in digital is that we have so many solutions. And I say digital electronics, but also just digital communications. And we will see in this class all kinds of modulation formats. And you might wonder, why are there so many? And the reasons there's so many is because there's so many different problems. And therefore we have a lot of different solutions. And one of my big goals for this class is to make you understand how you would find the right solution for a given kind of problem. Because when we do research especially, we're coming up with new solutions. And you have to be able to understand the context about why this solution would be appropriate, find the right application, because it could be a great solution for from here to the moon, but really a terrible solution for cellular. That's normal. So you just have to realize where you're working and what makes sense for that environment. So there are disadvantages. Digital isn't perfect. I said what the advantages are. And if I said there were so many solutions, so many ways of attacking the problem, that just means it's more complex. So much more variety of things you have to know about in order to apply digital. There's more signal processing, a lot of signal processing. A lot of what we cover is signal processing for communications. More synchronization. So you have to jump through a few more hoops to make your digital work, but it does give you those advantages I mentioned. It could be a little bit less efficient in bandwidth than analog is, but even though being efficient in bandwidth is very important, I'll be talking about that all the time, still the little bit of hit we get in efficiency is more than compensated by all the advantages I mentioned earlier. There is a very different breakdown of analog and digital. So I took the example of photocopying. So when I do, that's an analog, right? So every time I make a photocopy, it's getting a little bit worse. It's getting a little bit fuzzier each time. And maybe I have to work each time to be able to read the text or whatever, understand the image in my photocopy. But it's not like photocopy 3 is great and 4 is impossible. But with digital, it is like that. I go a certain distance and everything is fine. I go another distance, everything is fine. And then I go just a little bit farther and boom, everything, it's just gone. It's just no longer able to work. And we'll see that with the error correcting codes, that there is some point where they just break down and they can't correct it anymore. And then all those errors just flood through. And so this abrupt degradation. And if you, can remember broadcast television, when it was analog, it would be, like when you got a bad channel, it would be snowy, but you could sort of see it. And now if you have digital cable service, when it goes out, all of a sudden all the little blocks disappear and you don't have a signal anymore. You have no more image. So it's just an abrupt degradation. So another thing that varies between analog and digital is how we quantify what's good signal, what's bad signal. How do we measure the quality of a signal? With analog, we could measure distortion. We could send a sinusoid and get something that's not a sinusoid and sort of measure the difference. For instance, we could use the mean squared error between the sinusoid and whatever it is we received. We could use what we call the signal to noise ratio. The ratio of the signal power divided by the noise power. These are common ways of quantifying what an analog signal would be like. Distortion, we could use like third order harmonics, or there are many different ways we can measure it. But these are common. When it comes to digital, there's one thing we use, and that is the probability of error. I sent a 1, I sent a 0. What's the probability that that bit got flipped? And so we come down to, because it is a finite number of states, this is the, really the gold standard in determining the quality of a transmission. So it's a little bit easier in terms of there are fewer metrics that really matter. So this comes from the Sklar book, and it sort of tries to give you a flavor for what is a block diagram of a communication systems. And so we start here with what do you have to have in order to have communications? Well, you have to take your data and you have to format it. Like my voice has to become a digital signal for it to go. So as I have an analog signal, it's got to become a digital signal. Maybe I'm starting with a digital file and then it's easy that maybe I don't have to convert, but somehow I've got to turn my signal that the message that I'm trying to send into a form that can be transmitted over the link. So there's some sort of formatting. So now I've got the format, I've taken my text and put it into unary code or something. And now I have to actually turn that into a electrical signal. We'll call it pulse modulation. There's some electrical form to it now. And then I have to send it maybe on a carrier signal. So this is sort of baseband, and then this is band pass. And so maybe if I'm on a cellular phone, I've got to have a frequency which is supported by the cell towers. And then it goes over the channel, whatever that channel may be. Could be a wire, could be a fiber, could be a broadcast wireless. And then this is all in the transmitter up on top. It goes through the channel here, and then we come back up, and then we do demodulate, so get it off that carrier, detect it, take it from that electrical voltage and turn it into something that looks like symbols. And then if it was a voice, then we turn it back into voice or whatever we need to do. So that's certainly the basic components, but there's a lot of other things that we can do that are more complicated that maybe you didn't think about. So that's why he calls these the essential and the optional. So there are more complicated things that we can do. And I try to take this block diagram and tell you what it is in this class that we're going to cover, because we don't cover all of this, although I think it's all covered in the book. So we don't do source encoding, we don't do encryption, we don't do synchronization, and we don't do frequency spreading, and we don't do much multiple access. I guess I have it here. When I have time, I try to add multiple access, but I don't think we're going to have time. But we do channel coding, and we do multiplexing, and we do a whole lot of the other parts. Source coding, which we do not do, is a way of removing redundancy. So if I'm going to pay to send bits per second, I don't want to send bits that are unnecessary. And if we take there's many examples that would make you understand this. Let's take the English language. The English language has a lot of redundancies in it. I've seen where we take a paragraph of text and we knock out half of the words. And when you read the text, you have no problem, understanding, not half the words, half the letters. So some of the letters, when you see like the word is missing this letter, well, you know what word it is. And certainly when you have the context of the paragraph, you have no problem figuring out what the original text was, even though many points are missing. And that's basically because there's redundancy in it. The language is a little sloppy. We've developed the language, but we didn't try to make it tight and compact. Source encoding is a mathematical procedure that takes out all the redundancy so that we reduce it to the information that is absolutely essential to be transmitted in order to have that message get across. So it's really interesting, great. If you're interested in that, take an information theory class, and it's kind of cool, but we're not going to cover it here. So what we do instead is we assume that all of our information has been reduced to this core of essential information. And if that is the case, it is very well modeled as being random. Like there's no redundancy in it, so it's like it's completely unpredictable. So I don't know from one bit to the next bit what is going on, and so they're like completely independent data. And so when we attack this problem, because we don't use source encoding, we just assume that it's the equivalent of having used it and everything is in like this raw form. The next thing is encryption, decryption, very interesting topic, very important for security. But it doesn't really change the basic communication system, whether it's encrypted or not. So we don't need to cover that in order to really get an appreciation for the rest of the class. Channel encoding, this is forward error correction. So if source encoding was removing redundancy, in channel encoding, I'm adding redundancy. But the kind of redundancy I'm adding isn't the kind that makes it easy to understand grammar and language. I'm adding redundancy that makes it possible to correct errors. And so that's forward error correction. Multiplexing is where I try to have multiple users accessing the same channel. And that's very important for all kinds of systems, cellular, local area networks. Again, multiplexing and multiple access, they're sort of related, and we'll be covering them lightly in the class. And of course, most of our first half of the semester is on this pulse modulation, on this modulation baseband, passband. So that was the block diagram look at it. He also looks at organizing the material in the book according to sort of topics. And I'm adding, so we're not doing, like I do a quick overview of formatting just to give you the basic idea. And baseband signaling, I give you this like really quick in the first week, just so you have sort of a background, but we're not going to do it in any depth. Don't do source coding at all. I should have a green box about equalization. That's a mistake because we do equalization. And we do all kinds of coherent systems of modulation. I go over the non-coherent system of modulation. Why are there two? What are the differences, advantages, disadvantages? This is part of creating a big variety of solutions. We go over channel coding, and mostly this is in the form of forward error correction. Probably what I'm doing is I'm trading the multiple access for equalization because we don't have time to do everything. And so I've decided that this is more important in today's world than this. Okay, so I don't know why. I guess I did update it. This is the accurate one. I guess I have 2 slides and I should have gotten rid of the other one. Okay, so that is the introduction that I wanted to give you today. And today it has been me talking all the time. And I hope that we will definitely change that for next week. And just to remind you, you go to the section that says Course Notes, and it is there that you see the links to the video and the PowerPoint that you should be covering before our next meeting on next Tuesday.